Guillermo Bautista. Apa? Ini, ini loh. Iya, iya nggak sih? Oh, iya.
Okay, check. Am I audible? Good afternoon, everyone. Welcome to the fourth session of our 3D modeling and printing training series. In this session, we will focus on 3D modeling with GeoGebra. Since our distinguished speaker joined us from abroad, this entire session will be conducted in English. So I'm Irfan, and I'm going to be your master of ceremony for the afternoon. And to start our agenda, let us open this session with a prayer. Pray, begin. Finish. Thank you. And now let me introduce our expert speaker for this session. Here is a brief profile of his background. Dr. Guillermo Bautista Jr. is a mathematics education specialist at the University of the Philippines National Institute for Science and Mathematics Education Development. He has more than 2 decades of experience in training teacher and developing curriculum material from elementary school to the university level, focusing on the integration of the technology in teaching and learning of mathematics. Dr. Bautista has been training educators, teachers, and students around the world in the use of GeoGebra for teaching and learning mathematics since 2006. In 2012, he was recognized as the first GeoGebra scholar of the International GeoGebra Institute. He led the establishment of the GeoGebra Institute of Manila and has been one of the pioneers in integrating GeoGebra into mathematics education in the Philippines. Doctor graduate PhD in STEAM education at Johannes Kepler University in Linz, Austria. His research focused on integrating art, technology, and mathematics through GeoGebra in the form of function art. Function art refers to artistic creation that use curve of mathematical function. So, good afternoon, Dr. Guillermo.
Hello, good afternoon, everyone.
How are you today?
I'm good. I'm good. I'm well. So hopefully everyone is ready for this session.
Yes, okay. So it's a pleasure to have you here with us. And just a quick heads up for this session, Doc. You will have around 90 minutes for your presentation, and we will have a Q&A session.
Of course, of course. All right. So may I request some of you? There's an echo, so maybe I can request some of you to mute your computers, your laptops. I think to avoid the echo. All right. So good afternoon, everyone. Again. So let me share my screen. As our host, Irvan. Irvan, is it correct?
Yes, I'm Irfan. Correct.
Okay. So as our host Irvan told us, we will be learning about GeoGebra today, GeoGebra 3D. And I'm not sure, no, I have no idea if you have any experience or if you are currently using GeoGebra. So maybe I'll start a little bit slowly. Um, and then we can you can ask questions along the way. Okay. So there are two ways to do this. One is you can download GeoGebra on your computer, but since you are online, you can just go to geogebra.org classic. So I'll put it in the chat so that you can just click it. So there are many versions of GeoGebra, and I prefer classic because everything is in classic, and you really don't have to do a lot. So you can view a lot of windows in GeoGebra Classic. And for now, we will be using GeoGebra Classic plus GeoGebra 3D. Now, it is important that you learn a little bit about GeoGebra Classic because this is very similar to GeoGebra 3D, and you can use both windows um, at the same time. Okay, so um, I hope you open this window already. since all of you are online, so I don't think I don't think we need something that's offline. Right, so this is GeoGebra. This is GeoGebra Classic. If you are not familiar, I'm assuming that some of you are not familiar, so I'll start very slowly. You can see here, these are the tools that you can use for constructing uh, objects, for example, polygons, lines. So you can construct a line, for example. This is still in 2D, of course. Before we transfer to 3D, you can have the line segment, for example, and you can have the polygon. So there are many tools that you can use, no? And if you're familiar with this, then there's no problem. It will be better. And one of the observations that you can see when you construct is that as you construct in the graphics view, this is the graphics view. This is where we do everything. Also, the algebra view. So this is the algebra view. The algebra view. This is the graphics view. Is also populated with the objects here. So, for example, if I create a point here, the point is also added in the algebra view. Okay. So this is very good because this is promoting multiple representations. And once you move the point here, you can follow, of course, you can follow the tutorials. You can explore while I'm talking. You can also see that the point here is changing coordinates. So if I move point H, you can see that the coordinates here is also changing, right? You can also use this the algebra view. You can also use to input things like mathematical objects, such as, for example, if you want to graph functions. No? For example, we have already a g, and for example, you can type y equals x squared, for example. So you can also graph. No? You can also input things like another function. We already have the F, G, and H, so you have to be careful of the naming. So, for example, J of X equals sine X. Okay, so you can graph, you can create objects, and you can also save your file. So if you have a GeoGebra account, you can save your file by clicking on the menu here, and then clicking on Save Online if you have a GeoGebra account, or you can also save on your computer, or you can download. So save on your computer and download this is the same. Okay, and if you download or save, you have to save the GeoGebra file. So this is what you need if you want to open it later. So you have to be careful. Just save the GeoGebra file. For other files, these are different. They have different outputs. For example, later on, when we do 3D, you can save it as STL. If you want to 3D print it, you can save it as PNG, for example. For example, you need a diagram for your test, for example, or for a book that you are writing, or anything that you want to show the students, and you only need a picture, then you can save it as PNG. Okay, so this is a brief introduction of the 2D. And another one is that if you click some objects like this one, you can click on this icon here. This is called the style bar. So you can, for every object, there are properties. So you can click, for example, you can change the color. You can change the opacity. So if you want it opaque or transparent, okay, you can change the thickness of the object. So in this case, the thickness of the sides. If you click on the line, of course, you can see that there are different types of lines here. So this is easy to explore, and you can, of course, explore this later. but I'm just showing this to you to show you that there are you can do a lot with GeoGebra. So okay, so you have the colors and everything. Okay, right. So what else? If you click here, you can click on the keyboard here. You have the calculator, and the calculator is useful, particularly, for example, if you want to, um, for example, write uh, Greek letters. Uh, Write Greek letters, for example. You go here and then you click on one moment because so you can use Greek letters, for example. So especially those who are teaching mathematics. So they have the symbols here and other symbols. So if you're using logic like and then for the sets, element, subset, and so on and so forth, matrices even. Okay. So this is just a brief introduction. This is not really the main topic, but I just want you to I just want to familiarize you with the environment of GeoGebra. Any questions so far? Any questions? Okay, so if no more questions, and then maybe I'll give you 3 to 4 minutes to explore GeoGebra, and then if you have some questions, maybe we can have 3 questions after that. So here, 9:22. I'll give you 3 or maybe 4 minutes or 5 minutes. So at 9:27, we go to GeoGebra 3D. For now, just familiarize yourself with the environment, and then if you have some questions, I will answer them later. Okay? We can have 3 questions. We cannot have a lot of questions, of course, because we need to proceed to GeoGebra 3D for the modeling part. Any questions? Okay, so 5 minutes. It's 9:23 here. We see each other at 9:20. All right. So any questions so far? No questions?
No question, sir.
All right. So let's proceed to TD. I'll turn off my camera because I get distracted of this. Here. Okay. So anyway, I'm seeing my screen. So all right. So um for GeoGebra 3D, you can display actually GeoGebra 3D by clicking on this menu bar here, the menu box at the top right. And as you can see, if you go to perspectives, so maybe you see file and then edit and then perspectives, you can go to 3D graphics. And let's see what happens if we display 3D graphics. Okay. So as you can see, it became 3D. Or if you can view, instead of perspective, you can also go to view and then you display both. So you can see display graphics and algebra are displayed. The 3D graphics and algebra are displayed. You can also click on the graphics. This is what we had earlier. Okay. Okay. So as you can see, what is displayed here is also displayed. You can use your mouse to um, zoom in and zoom out, and you can also use the zoom here. Okay. So there are two things that I want to highlight here. Maybe we can delete some objects so it's not so crowded. So I'll delete the graph. So you can, in deleting, you can just click on the object and click delete on your keyboard. Or you can also right click and then delete. It's also possible to do that. So I'll just have one object. I'll have the polygon. So we don't, so the window is not so crowded. Okay. And what do you observe? So one observation that you will see is the polygon is actually on the XY plane. I don't know. I know a lot of you, I know some of you are not mathematics major, but in 3D, in high school mathematics, you learn that you actually have the XY plane, right? So this is when you graph, for example, when you graph when you were in high school, for those who are not teaching mathematics, you have the x-axis here and you have the y-axis. And in 3D, these are equivalent to these two um, axes here in the 3D. So the x is actually the red, the y is the green. So if I do it like this is actually how it looks like. You are on the top view, and the z is the blue axis. So x, y, z, red, green, blue. The order is red, green, blue. Anyway, it has a label, so you won't be confused. Okay. So for example, you can drag this. You can drag the window, for example, using this move graphics. Okay. Yes. Okay. Or if you want it at the center, you can click on move and then here. Okay. So how do you move the object, by the way? Every time you move the object, you have to click on the move button. So in the 2D, you can move the objects. So I suggest that you draw also a triangle and click. Use the move tool to move the vertices. Okay. And you can also move the sides, these sides, for example. Okay. So as you can see, you can also move the label. Okay. So you can remove the label by right clicking and then clicking on label. So if you don't want the label. Okay. So this is the XY plane. Okay, so observe two things. First is that when you click here, note, look at this, the graphics. This is the toolbar. So if you click on the 2D, this is the 2D and this is the 3D. If you click on the 2D, this will change. It will change to the 2D tools, of course. And if you click on the 3D, it changes to the 3D tools. So this is one of the confusions of the students. So you have to be familiar that, of course, the 2D tools are different from the 3D tools. Any questions so far? Are you following? Any questions? No questions so far. All right, so for now, we will not be needing the algebra view. So we can actually remove these or hide them using again, the menu here. If you go to view, you can actually choose to display or hide them. So you can, for example, uncheck the algebra view here. So if you uncheck, it disappears. Of course, it does not really disappear, it's just hidden. Okay. So we only have the two views here. Okay, so dragging in the 2D is easy, but dragging in 3D is a bit complicated. Is a little bit more complicated. So for example, if I remember I'm still in the move tool. If I drag here, notice that I can of course manipulate the window, right? Okay. Now notice that if I click on or if I point on the points, I think one of the microphones is open. Right. So um, notice that if I point the mouse pointer on any object, there are 4 arrows, right? So what does it mean? Meaning, if you drag the point, you are just dragging on the same plane. What do I mean by the same plane? Meaning you are still on the same. This is the plane here, right? Meaning you are dragging horizontally. So it's either left, right, up, down. Okay, so up, down, left, right. But you are moving away, not moving away from that plane. Okay. So it's like you can think of this as the ground. You are not moving up the ground or moving down. So you are in the same level. Okay. So this is if you click on, if you see the four-headed arrow. So the question is, how do you move up and down? This is very important. This is very simple, but this is very important, and it is important that you understand it because otherwise it will be harder later. So if you drag, if you point, it's four-headed arrow, but if you click, look what happens. It becomes an up and down arrow. So if the arrow is up and down, meaning you can move the point up and down. Okay. You understand? So up, if I look at this here, what's happening? Okay, so it's not one of the points is not on the XY plane, not on the ground. No? If you can think of this as the ground, no, for the non-mathematics majors. So it's up the ground. What happens here? You cannot see the triangle. You can only see the line. From the mathematics teacher, why do you think that is? What do you think this is the case? Anyone can guess for those who are teaching mathematics? Now, the reason why you can see it here, because if you can think of this as the ground, you can only see things here that are on the XY plane, on the ground. Once it's below or above, then you cannot see it here. Okay. So if I move it again here at 0, then you will see it again. If I move it down, then you will not see it again. Okay, so this is the concept, the mathematical concept. If I click again, remember that if I click again, it becomes the four-headed arrow, which means that I can move it actually anywhere. So it doesn't get out of the XY plane, doesn't get out of the ground. But if I click again, so it's for this, it seems that it's out of the ground, but actually it's not. So if you actually arrange it like this, it's still on the ground. It's just that it's far. Okay. So that is dragging in the XY plane. Okay. Of course, aside from dragging, you can use the algebra view. If you are familiar with the XYZ, if you're a math major, I think you are familiar. So this is the X and the Y coordinate. So maybe we can work with 1 point. Let me delete this and just work with 1 point. So as you can see, this is the XY coordinate. You can actually display the coordinates. We have a recording of this. So if I'm too fast, you can watch this again later. So if I click on the coordinates, you can see that it's 6, -2. So for the math teachers, you know this. The X coordinate is 6 and the Y coordinate is -2. And the Z coordinate, you are 0 here. If you look at the XY plane. And if you move up, cannot see the point because it's not on the XY plane. So it's 3.48 above the ground, units above the ground. If this is -5.53 units below the ground of, which this is below and above. And if you make it 0, then it is on the ground, which means that you can see it on the XY plane. Okay. So this is a bit technical, but I want you to understand this because this is very important later when you are modeling. You have to know, you have to understand dragging on the same plane. Like, for example, here, if I drag here above, if I click it again, I can drag it anywhere, but notice that I'm on the same plane. The 4.53 here is not changing. So even if I move here, only the X and Y are changing. So meaning I am on the same height. Can you see the 4.53? But if I click it again, then I can move it up and down. Okay? So that is the basic of dragging in 3D. Any questions so far? I hope it's not too technical. I'm sorry for this, no? But you really need to know this. Uh-huh. Just to give you a bit of taste of what I'm doing, I do a lot of GeoGebra modeling, so I'll show you some before we begin. This is my GeoGebra profile. And these are some of the models that I've created. So I've created a lot, actually, using GeoGebra. So these are only a few. These are not all. I've created a lot of models. So for example, you can do for example, umbrella. This one is uses the slider. So you can do things like this in GeoGebra. And you can also 3D print, which is, I think, the goal of this this workshop. So I've created a 3D model of GeoGebra, of the Taj Mahal, for example. Now, this is very hard to drag because it requires a lot of computation and it's very slow. So I have printed this. I will show it to you later. But what I'm trying to say is you can do a lot of in GeoGebra, just like what you can do probably in your 3D modeling software. So for example, if you're teaching 3D, maybe we can do the truncated cube later at the end of the workshop. Okay, so this is, for example, the 3D chair that can be found in JKU. So I modeled it. This is the actual chair. So you can do something like that. Okay, so now we start with the actual 3D modeling. Now that you know how to drag. So I can go to GeoGebra Classic again. GeoGebra/Classic. Okay, I have to delete and then I can go to I will go to view and then 3D graphics. Okay. Okay, so how do we model? We can start with the basic 3D shapes. Of course, you can click here. You can go and create a cylinder, for example. The most basic, of course, is the cube. So how do you create a cube using GeoGebra? You can just click here. Again, don't be confused. If you are here, you will not see. If you click on the 2D view, you will not see the cube because you are on the 2D view, so you will only see the 2D objects. But if you click here, you will see the cube. Again, I don't really need this now. And then I can go to the menu box and then I can hide the algebra view. Okay, so you have this environment on your computer. Now, if you cannot follow now, then you can do it later, but let me check. So do you have this on your computer? Okay. So how do we create a cube? Very simple. So click on this icon here. It looks like a pyramid and then just choose cube and then just click 2 points and then you can have the cube. Actually, you don't need this if you don't want to. If you don't want this to appear, you can just click again on this menu and then click on view and then maybe we just not display this for now. So we can hide the graphics view. Okay. Of course, you can resize the cube. What does the points mean here? The black points, you cannot move them. So if you try to click on them, you will only move the 3D view. The one that you can move are the blue points. So there are several blue points here, but as you can see, you can only move the two. So the darker blue, you can move them, but this one is, you can also move, but not the size. So you can resize. Again, so you can see the arrow, right? So meaning here you are not getting out of the XY plane. Okay. Any questions? So you are on the XY, meaning that the bottom of the cube is on the XY plane. By the way, you can remove the XY plane if you want, XYZ plane. 'You' plane. 'You' 'can remove using this. 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 'You' 'can remove us So you can click here, you can actually remove. So if you want it, you can display or remove. Again, I go here. I click outside because if you click this, this will appear differently. So the tools, different tools will appear here. So if you want to remove, for example, the XY Z axis, you can just click anywhere outside the cube. Do not click the cube, and then you can click the the toggle bar here, and then style bar, and then remove this. So you can do that if you want. Okay, for now I'll display it. So as you can see here, the bottom of the cube is in the XY plane. And I will show you what happens if of what we have learned, if you drag. So of course you can resize the cube. You can move the position. And again, if you don't want the bottom to be at the XY plane, then again we can move the points above and below, right? So again, you click twice. Now it's XY plane, the four arrows, but if you click again, it's up and down. So you can actually, so as you can see, the cube is tilted. Have you done this? Okay, so if you want it back, then you can have it back. Okay, you can also tilt this. You can tilt this one. But for the black points, you cannot move them. Right? So, right, suppose that you want to change the color of the entire cube. You can change, by the way, the color of each face, for example. So individually, you can change it. Like, of course, you just have to click it, and if you want it green, you want this blue, for example, you want different colors per side. Okay, so different colors. But if you want to change the color of the entire cube, you can go to, it's quite hard here. So you have to go to the algebra view. And you can click here, you can see the different objects, meaning you have to click this one, the entire cube, and change its color if you want. So everything will be green. Click here again. Okay. Of course, you can change the different colors also of the points. Okay. And as you can see, the points here, the black points are not displayed because they are what we call auxiliary objects. Okay. So later I will teach you if you want it to be displayed here. But usually we hide them. So we can actually hide the points. Sometimes you don't need them. So for example, you want your cube to be clean. You don't want to see the edges. I mean, you have the edges, but very, very thin. So you can click here. You can click on the edges and then make it 0. See? So if I want this green and I want the edges to be 0, or maybe you want it to be very small, the edges to be very small, maybe 1. Okay, so we have an edge 1 here. And then, for example, you don't want this to appear. You can just right click and you want the cube to be clean. Okay. Okay, again, I can remove this if I want. I can click outside the cube, click here, and then remove everything. So now I have a clean cube. I can just hide everything. And I have a clean cube. These two you can display again if you want to resize. Right? Okay, as an exercise, I don't want to talk all the time. So as an exercise, maybe you can create something else. Maybe you can create a prism or a cylinder. So for example, for the prism, for the cylinder, for example, how do you do it? You can create 2 points and then, okay, so you can create 2 points first. This is the problem without the, so you can display this again. So you can create 2 points. Okay, and you can create the cylinder using the 2 points. So 2 points, you can have the radius, for example, 2. So you have the cylinder here. What if you want it to be vertical? Of course, you want the points to be on top of each other. So this is, what does it mean if the cylinders are on top of each other? You have to have the same xy, right? So for example, the easiest way to do this is just to create 2 points on the same plane. I will hide the cube. I can hide this. And then just the easiest way is to just create 2 points on the z axis. So they are on the same, they are like vertical. So I'm just, I clicked the point on the origin, 0, 0, 0, and then click the cylinder, and then type the radius, 1, for example. So I have this cylinder here. And again, you can clean it up, maybe 1 or 0, and then remove. Okay. And then sphere, you can also do that. What else? Prism. What does prism mean? Okay. For prism, you can for prism, you can actually create a polygon first. So create a polygon first here, and then extrude. So extrude tool and then height. Okay. All right. So any of you can create any of these. You can create a cylinder, a prism. The easiest would be, of course, the cube. Again, I can show you how to create the prism. You can also do graphics. If you want, you can do here in the graphics first, like you can use a regular polygon or polygon. So you can draw here. Regular polygon, for example, you want to create a pentagon. You can click 5. So there are five sides, equal sides, and then go to graphics, go to the 3D graphics, and then go to extrude. Where is the extrude tool? Extrude to prism. Okay, anyway, we will discuss the prism first. So just create the cube and clean it up for practice. So create the cube first and then clean it like what I did. So I'll give you 5 minutes to do it. Again, cube is very easy. You can just click the cube tool and click on another point. So you have 2 points and then create a cube. Okay, can I give you 5 minutes and maybe some of you can share their screen later just to display the cube that you created. Again, we need a clean cube, no points, and then you can choose your own color, and maybe you can choose the thickness of the side of the edges. Okay, 5 minutes. And then we can display the cube later. Maybe 2 or 3 participants. If you have any questions, I'm just here. You can type or you can just open your microphone. 5 minutes, 9:57 here, so at 10:02. Okay, so did anyone created something? Hopefully, anyone wants to volunteer to show their screen of what they have created? You can raise your hand, or are you shy? Anyone? A clean cube without the points, and then um, thin edges. Okay, so it looks like they are shy. Okay, let's continue. Right, so the next one is very simple but very useful command. So what we can do, I can create a clean window. Again, I can go to GeoGebra Classic, and then I can go to View, and then 3D Graphics. And then I don't want the algebra view for now. So one very important command in or tool in GeoGebra are the extrude tool. So you can extrude to pyramid and you can extrude to prism. So sometimes it is easier, especially if you are new, to just create something on the 2D view and then extrude in the 3D view. And of course, two very useful things or tools that you can use is the polygon tool. So you can use a polygon tool, for example, to create any type of polygon, but not regular polygons. So regular polygons, I don't know how you say it in Indonesian, but regular polygons, of course, are polygons with the same lengths of sides. No? So, for example, you can create a polygon, a triangle that have different sides, right? Different lengths. But if you click on the regular polygon, of course, you will have an equilateral triangle. This says this asks you for the number of sides. So if you type 3, you can have the equilateral triangle. So these are the difference between these two sides. So you notice that if I clicked here, what happened when I clicked here? So I draw another polygon. So you have to go again, you have to click on the move tool if you are finished doing it. So you can move the points or the sides or objects in general. So we don't need this. I delete it. So I think you can see the difference. This is a regular polygon, which means that I have an equilateral triangle. And of course, I can do another one. I can do quadrilateral, a general quadrilateral here. But if I use the regular polygon tool and create a four-sided polygon, then of course I'll have a square. Okay. Okay. And as you can see here, whatever I draw here again, it's also on the 3D view. And all of these polygon are again on the XY plane. For mathematics teachers, I think this makes sense to you, of course. Okay, so what is the difference um, between the extrude to prism and extrude to pyramid? Of course, we can do the extrude to prism first. We just click on the extrude to prism tool. And again, you can only see this when you click on the 3D view. Maybe you are looking for it. If you click here on the 2D view, you cannot see it here because the extrude to prism tool is only available for 3D, which means that if you want to do it, you have to click on the 3D view. Of course, you can hide the graphics view if you want. If you're done, we can just purely work on the 3D view. So for the extrude to prism, you just click it and click on the polygon in the 3D, and you will be asked for the altitude or the height. So just type a number. How high do you want it to be? What is the altitude? You can type 1, or maybe 2, or maybe 3, or maybe 4. Okay, so these are our prism. So here the height is fixed because we already type it. So whatever we do here, like of course we can drag the points here. It will change the shape, of course, of the polygon, of the prism. Okay. Okay. And again, you can, of course, drag. If you remember what we learned earlier, we can drag, we can tilt by dragging on the up down. By clicking on the point and making sure that it's up down. The icon is up down. Of course, we can do it. So it's a little bit tilted. Okay, so you can do it. And again, you can, if you want, you can clean it up. You can change the color. You can change the properties. So you can go to algebra, for example. Okay. So in some cases, you will see that the objects here, sometimes you can see this, like it's messed up. But if you want to group them, by object, so this is by construction, by the order on how you created it. But if you want to group them by object, you can just click here, this icon here, the toggle style bar, and then click this icon here and group by object type. So here, every point goes together, every polygon goes together, and every prism goes together. So this is easier to handle because once you click, for example, the prism here, you are clicking the entire prism on the 3D graphics view. So here we can again change the color, change the properties as a single object. If I can make this blue, for example, can make this red. Okay, can make this if you want more colors, you can click on the plus here, plus button here, and then you can have more colors. Okay, maybe I want it the cyan color, like this one. Okay. Okay, and again, if you want to select everything, you can click. So you can see you can collapse and you can expand, and you can select all the objects, for example. So again, if I click on the name here, everything is selected, and then I can change the properties at once. Okay. And of course, for example, if you want to change the segment, all the segments, this is the segments in the polygon, you can change also the color. Like, for example, if I want it black, for example. I don't know if you can see it, but maybe I can. So it's actually the bottom part. Okay. So of course you can click individually. You want to change the color of the sides, as I've told you earlier. If you want to change individually the side, if you want a polygon with or a prism with different colors per side, then you can just click the, oh no, not the side, but the face. You can just click the faces individually and just change the color. So you can also do that. Okay. Any questions? Any questions so far? This is recorded, so you can watch this again later and practice. Okay, so maybe we can have 3-minute practice for creating a prism, And then okay, there's a comment. It's clear so far. Very good. So after this, we go to 3-minute practice first, and then we go to the pyramid, but this is very similar. 3-minute, 10, 12, 10, 15. Okay, so I share again. So pyramid, extruding the pyramid is very similar. So I'll clear my window again. Extruding to pyramid is very similar. Very similar command. Go to graphics again and remove the algebra. So if we extrude the pyramid, again, I draw some polygons, I draw some pentagon. And then a regular pentagon again. And maybe one hexagon. So this is 6 for hexagon, and I'm gonna draw maybe a triangle for the other one. Okay. So if I go to graphics view, I can again go to extrude to pyramid, and just click on the polygon on the 3D view, and just again type the height or the altitude. So 2, maybe 3, maybe 4, and maybe 5. So again, these are very basic shapes. And you can, of course, change the shape and the size either on the 2D view or the 3D view. Okay. So both here you can also change the size. Okay, so any questions so far? Very similar. Okay, so what else are the other shapes? You can have the cylinder, the cone. That's basically the 2D. So if you want a cone or a cylinder, you can also use of course, there's a cylinder tool, but you can also use the extrude tool. So if you have a circle, we can have two circles here. You can use the extrude tool. I'm not sure, but I think I've done it before. So go here and you can also use the extrude tool. Prism becomes a cylinder. And of course, the pyramid becomes a cone. So I have to change this to pyramid and this becomes a cone. Okay. So that is the easier way to do it. Of course, you can do it manually. You can do it manually using the points. So it's quite hard to align the points on the Z, unless you, of course, do it on the Z-axis. Like, for example, I can do it here. Maybe I can have a cone here. You can have 2 points. So I use the point tool. And I make sure that they are both on the Z axis. And then I can just click on the cylinder tool or the cone tool. You need 2 points. You click on the 2 points and then just type the radius too. This is the radius of the base. Okay, so that is my cone tool, right? So it's above, it's floating in the air. Well, in the air, quote. Any questions? Okay, so do you want to practice? Maybe create one of these shapes or maybe combine them. Later, we're going to create a custom solid. The next activity, we will create a solid with this shape. This one. Oh no, not this one first. It's the easier one. Oh, I can find it anyway. Oh, this one, I think. So we will create this one. The next task is we create this one. It's a custom solid. We need to create something like this using using different strategies. Right. So I'll give you again maybe 3 minutes. We don't have a lot of time. We have to accomplish this one and the one that looks like a house earlier that I showed you. Task 4, this one, before we finish. So 3 minutes to play on the cylinders maybe and the cone. You can create something like it. Like them, you don't need to use the extrude tool if you want. So it's up to you. Right. So maybe 3 minutes. Okay, so I have an advice here that I suggested that maybe I speed things up so you will learn more. Of course, we have a recording. I'm not sure if you can follow, but I will try to make uh, the last three models will be a bit faster so that you can learn more from this session. Maybe you cannot follow because it's fast, but I think you will learn more because you have the video and you can just follow it later. Would that be okay? So we create three objects. We create the custom solid that I told you earlier. Where is it? This one. They are both task 4. And then this one. Yeah. Please put the chat. Please put your question in the chat. And maybe we can have something like the truncated cube. So we can have this one. So we create three different tasks. This is a bit fast, but anyway, you have the recording, so you can watch it later. Would that be okay?
Yes, sure.
Okay, great. So the first one is, how do we create something like this? This is a custom solid. You don't have any tools here. There's no tool. You go to 3D graphics. There is no such tool. So we have to find a strategy to create it. For example, you want to print this. You want to print this kind of solid for your student. You want to 3D print. So how do you create it? So there are many strategies, of course. One strategy is for learning more tools. So one strategy is, so as you can see here, if you see from the top view, you have a 2 by 4. The base is a 2 by 4 rectangle. Okay, so we can do this here. Maybe a 2 by 4 rectangle. Maybe I can create points here. It's easier. This is 2 by 4 rectangle, and then I cannot use the extrude tool because of this. So what I can do is I can just use the extrude tool for this part, the cube part, and then I do something else for the triangular part. I don't know if you get the idea, but this is a cube, right? This part here, and this is like a triangular prism. So what I do is I create, this is only one of the strategies. So maybe as an exercise, you can think about the other way of doing it. So I remove this and I click on this one. And for this one, I can create a polygon tool. This is a square, of course. And just, this is 2 units, 2 units by 2 units by 2 units, which means that I can just extrude this. I just can extrude this for 2 units. So I can extrude here for 2 units. And then I accomplished the cube part. Okay. So maybe this is one way of doing it. Okay. So how do I accomplish the triangle? Well, we can just create a polygon for the base here. And as you can see, if I see the polygon here, I also see it here. And then use the polygon tool to cover the faces. Okay, so maybe I remove this. I remove the plane. So it's easier to see. So I use the polygon tool to create the triangle here. Remember the polygon tool, you have to click on all the sides and then come back again to the first side to close it. Okay. So this is another polygon. So I already have the triangle here. And I create another triangle here. So that's 2. And then I have to cover the diagonal rectangle. So I click on one of these, first side, second side, third side, fourth side, and then back again to the first side to close it. So this is it. This is practically done. Okay, so I can just clean it up. So again, I can group this by object. Maybe I don't want the points. By the way, instead of right-clicking here, you can also remove the points here. So just click and you will see that if you click the circles here, the point is hidden. But you can bring them back by just clicking them again. Okay. I don't want this also, these other points. Remember, my goal here is to do 3D printing. I don't want the labels, of course, so I can just right-click them and remove them. So I can drag the label, and sometimes it's hard to remove them, but oops. Of course, you can do you can, oh, this is one problem, by the way. By the way, if you don't want things to move, you can just right-click them and then you can click them and then click this button here. This is the lock button, which means you can fix the object so they don't move. So once the object is fixed, you cannot drag it. So in many cases, like this case, you don't want them to move. You can just lock them and they will not move, like what happened earlier. So no matter what I do here, nothing will happen. Okay, so you can do that. Okay, so again, I don't want the labels. I don't know what's happening, but the points shouldn't be there anymore. Well, this is some bug, really. This is a GeoGebra bug. Sometimes you remove them, but sometimes they don't disappear. But there shouldn't be any point here. Yeah, so it's just a bug. Once you export this, the point will disappear. Okay? Right. So what do I do now? I, of course, clean the object, quadrilateral. So I think it's somewhere here. And then if you want, you can make the color solid. So in the prism, you can make this solid. You want this green, for example, you can make this solid. It is interesting that it's still here. Anyway. And then you can make, oh, by the way, you can copy the visual style. So if, for example, if this is green and you want everything green, you can just, it's like the copy visual style in Microsoft Word and in other. So you can just click this and then click here. And then, of course, you can click the bottom. Mr. Andre, have they done 3D printing before? Have you done 3D printing before in the session?
Yes.
Okay, so if you want to 3D print this, you can just export download us the STL. There is an STL file here. And maybe you can open it to make sure that it works properly. You can open it in a 3D modeling file, like maybe Tinkercad or whatever you're using, to check if it will print properly. Because of course, GeoGebra is not so much for 3D printing. So you have to check first before you print. Okay. So that is one strategy. Another strategy, so you can create, of course, you can do different strategies per modeling, is by just choosing maybe everything is polygon. So you can do that also. I will make this a little faster. So if we choose polygon for everything, so we put something on the center. So for the mathematics majors, I have to move the B up by, this is 0. So by 2 units. So I can create another input B, but I move it up by 2 units. So this is again 3D coordinates. And then what else? The C, I can put the third coordinate for 2. And then what is the B, and this is the middle one, E and F. So I can, for E and F, because we use the problem here is, so for math majors, maybe a little bit of vectors. I'm sorry for this for the non-math majors, but of course you can just type the coordinates, of course, like what is the coordinate in XY of this? Maybe it's too much. Vectors is too much. So what is the coordinate here? This is -1, 0. So this is -1, 0, and then the Z is 2. And then the other one is 1, 0, 2. So you can always type the coordinates. And then just use polygons. So for example, for the base, I can just use the polygon tool. Again, you can use the polygon tool. You can use the polygon tool even in 3D. So I can create the rectangle here. And then I can create the side. The side is a trapezium or trapezoid. So I can just create a trapezoid here. And the trapezoid on the other side. And then, so I'm teaching you different strategies just to learn the tools actually. But of course, any strategy that does the work is fine. And remember, sometimes it's very tricky because, for example, this one, it looks like that it's complete, but actually there is no plane here at the back. So I still have to have another one here. Again, I'm repeating this so that you'll remember. You don't need the points. We can fix all the points, by the way. So the movement is limited. So we can go to settings and then click on all the points. Or maybe just click on the points. So it's creating a polygon. Click all the points and then I don't know what happened. I think because I was clicking this one. So sometimes if I am thinking if I can, okay, so it appeared, the lock here. So you can click everything and then lock. So they don't move, okay? And then you can also lock the individual points here if you want. Oh, everything is locked. This one is locked. Oh, looks like everything is locked. So good. Remove them. Hide them, I mean. And then change the color, whatever color you want. Clean it up. And then remove the labels. You can remove the label, I think, by clicking on the name here and removing the label of everything. So just click and then uncheck. So all the labels are removed. Maybe there are segments with labels. There are polygons. There are still segments with labels. So no more. So you can have the solid color just like earlier if you want. And we are done. Any questions? A cylinder, a cone. Yeah, of course. If you want to combine the cylinder and a cone, well, of course, the process is a little bit different. So maybe you can have 3 points. Okay. And then at the bottom, you have the cylinder. One, for example. And then here you have the cone. Of course, you have to have the same radius. Oh, sorry. Should be cone. Okay, so that's it. You can, of course, adjust the height of the cone. And then just clean it up, just like we've done earlier. Any question aside from the... Any other question? Are we must lock the... Yeah, depending on you. If you don't want your... there is a question in the chat. Do we lock our object before we save? Well, of course, if you don't want anything to move, it's good to lock the objects. And there is another question. What are the limitations of GeoGebra for creating complex 3D models compared with software like Tinkercad or Blender? Well, the limitations, I don't know if you can call it limitations, but GeoGebra is more mathematical. It is different for example, Blender is really for complex 3D modeling. So if you want to model like a car, I don't think it's advisable to do it in GeoGebra. So GeoGebra is for something that has to do with mathematics. I think that the limitation, of course, of GeoGebra is if you have a very complicated model, then sometimes it can go really slow. Like this one, for example, I created this model of the Taj Mahal. So you cannot almost rotate it because it's very heavy. And it's difficult to if it has a lot of objects. So this is almost like a picture, but this is actually a 3D model. So if I rotate it, it's very hard because it takes a lot of time because it has a lot of mathematical objects. Tinkercad is easier because you can just combine objects. I think it's more of, but of course, there are very, very complicated models also that you can do with Tinkercad. But if you are serious about 3D modeling and engineering, I think it's not advisable to use GeoGebra because, of course, you can use Blender and Fusion and whatever you're using, AutoCAD. So these are really for engineering. Okay, so what else? So I have shown you the 3D tools, but there are things also that you can use like the lines. So here I'm going to teach you how to create something like this. So this is there are many strategies to do it, but here we use the lines and and the line segments. Okay, so we'll do something like this. So the easiest way to do this is, of course, start from 2D again. You have the base. So let's have like a 2, again, a 2 by 4 base. So we can draw the polygon and then go to 3D. I will make this quick because we don't have a lot of time. And then if you want, you can extrude again using the prism tool. Oh, we have the prism tool, by the way, but we are using the extrude tool. Maybe 4, maybe too high. Undo, and then maybe 3. Okay, so my problem here is how do I make sure that this is in the center, right? So there are several things that you can do. For example, you can, for the mathematics majors, you can probably do x equals 0, the graph for x equals 0. So you can type here x equals 0. So that divides the plane, the rectangle. But for the non-math majors, we can do it by using the midpoint probably. So maybe to make sure that we are in the center, we can use the midpoint tool. So this is the midpoint tool. Okay, so we have the center. And we need to have not this one. Should really close this one. We can create a line that is parallel to the z-axis. So in GeoGebra 3D, just like in GeoGebra 2D, you can create parallel lines. So if in GeoGebra 2D, if you have a line, for example, so let's go to 2D, you can create a line that is parallel to this, passing through a single point. So I can use the parallel line tool here. We are in 2D, we are not in 3D, so remember. So I can click this and do this. So meaning whatever I do here, the two lines are parallel. Okay. So this is the theory of Euclid, if you remember, for the math people. So for if you have a line and a point not on the line, then there exists a single line that is parallel to the line passing through the 2 points. I think you get what I mean. That is also possible in 2D. So here I can use in 3D, there is also a parallel line tool here. I can click the point here and the line here, the z-axis, and then I click on the points. So I have two lines that are parallel to the z-axis, meaning if we consider the z as a pole from the ground, then these two are also poles that are parallel to this. So depends on you what height do you want. So maybe we can have 2 unit from the upper face of the prism. So maybe I can create a point at 005. So this is the point here. And then again, I can use a parallel line. This time parallel to the y-axis and then passing through G. So I click the y-axis here. I already clicked, so that's why it produces the line. So again, I click on the y-axis and then I click on G. Okay. So I'm sure that these two lines will intersect because, as you can see, this is the midpoint, which is at x equals 0. I intersect the two lines and then the two lines here. And then now I can create my roof. I just hide them. And now I can create my roof. The triangle is the roof. Okay. So a rectangle here, another rectangle here, and of course, the two triangles on the side. Triangle here, and another triangle on the other side. Okay, so this is basically it. You just need the cleaning. Any questions? Have you learned something? Hopefully you learned a lot, and you will learn more once you practice on your own and you watch the video. Okay, the last one. We have 10 minutes. Oh, I forgot that we have a discussion. Do I need to pause, Mr. Andre?
No, you
Do I
can
need to pause,
continue.
or do I need to finish? Or
You can continue. Maybe we can discuss in 5 minutes after.
yeah, I have time. We can extend if the teachers have time.
Okay.
Okay, so the last one. The last one is we do the truncated cube, something like this. So we have a cube, but then we cut the corners, right? So I'll do this very briefly. So I go to 3D graphics. I just can use the cube. I can use the cube tool. You know, sometimes I'm really comfortable with using the graphics first. So I want to have a cube that is 6 units long. So 3 here and 3 here. I forgot about the 30-minute discussion. Okay. Okay, so it's quite a big cube. I don't need it because I only want the vertices. Or maybe I need it. And then I want to cut. That's why the reason why I made it 6, because I want to cut like 2 units. So it's the cut is 2, and then you have a remaining 2 here, and then you have another cut of 2 here. Okay. So how do you do that? I can use the cylinder. Again, for cylinder, you can have 2. The one with a specific radius. If you use this, for example, back click this as center, I can draw any cylinder, right? Any with any length. But I can use the second one. Oh, sorry. I was talking about cylinder. Sphere, I mean. So I can use this one, I can just have a radius of 2. So I know that it's fixed. And then I can do the intersection. So I can intersect the cylinder and the edges of the cube. Or sometimes it's difficult to see, so you have to drag the window to have the correct position. You will see that if it's the intersection, because I don't know if you can see, it's like a tetrahedron. Okay. Okay, so this is my cut. I remove it, and this is actually my cut. Okay, so if I remove the cube, this is my cut. Right? Of course, you can do this also on the other edges, like cylinder, and then intersect, and then what else? Cylinder, intersect, and then do the triangle. But we can just rotate this. So we can rotate the triangle about the line. So triangle, rotate where? Or rotate around what? Where? The z-axis by 90 degrees. So that, okay. And then we can also, I think we should rotate also the points. because we need them. Okay. Another rotation. But then again, you can, for the non-math majors, you can simply do what I did earlier. Just create a cylinder and create a sphere, and then just do the intersection and the triangle. But this is easier, I think. Less steps, less number of steps. Okay. Okay, so the easiest way, of course, is to reflect this, but I think it's too much. So we can do again the cylinder at the bottom. So let's put the cube back and then create another cylinder here. So you have another practice. Create a cylinder here. 2, the radius is 2, and then also again, of course, we can do it. Let's do it on all the sides. I think we don't need this window anymore. So we can just remove them and then do this. Okay. And then remove the object and then put the triangle. And then again, remove the cube. Can remove the cube. Interesting, because I don't know what happened, but the sides are there. The sides are not supposed to be there. So this is another bug probably of GeoGebra. Again, we can rotate by 90 degrees. I think you get the idea. Almost done. We have 3 minutes, but we are done. Of course, for mathematics majors, you can also use the reflect. So maybe create a plane and then reflect about the plane. But we can just use one tool, so it's not so overwhelming to many. 90, 90, 90. I'm rotating the objects by 90 degrees about the z-axis in case you're wondering what's happening. And the last rotation is here. 90. We need the points because we need the polygons later to connect. 90, 90, and 90. Okay, so I think, again, this is the bug. This is annoying. Oh, it's gone. Okay, so just the last one is just to connect everything. So connect the faces, right? We can also rotate, I think. So we can rotate this by 90. Rotate this by 90 also. We have 1 minute left. rotate by 90. And also, of course, the top and the bottom. So from here, we create a polygon for the top and the bottom. But I guess you can see that this is the truncated cube already. Of course, you just have to remove the points. Okay, so 1, 2, 3, 4, 5, 6, 7. Okay, so we have a truncated cube. We just have to clean it up, and maybe we don't have time to do it, but I think it's easy. I think you get the idea, and just remove the points, and so on and so forth. And that's it for the modeling. Where should I click on the point before? Question is, where should I click the point before clicking rotate? You have to click on the point. There are cases that you miss the click, but you have to you just have to do it again. Click on the point or any object and then click on the where do you want to rotate it. Maybe here we want to rotate from the z-axis. One moment. Okay, so any questions so far? So this is basically it. This is the end of our modeling session. So if you have questions, please you can ask them on the chat or you can raise your hand. Thank you. Any questions from the participants? I don't know if someone is speaking, but you are muted. We don't hear you.
I think there is no question from offline participant here, so
Okay, so no questions? Okay, so thank you very much if there are questions. But of course, later on, maybe you can ask Mr. Andre if you have any questions, and of course, I can answer it. Thank you very much.
all right. Thank you very much, Dr. Guillermo, for the clear and insightful presentation. And thanks to our participants for your active engagement. Please remember to fill out the attendance link and also questionnaire provided by the committee in the chat box. And maybe that's enough for today's session. I'm Irfan, signing off as your MC for this session. Thanks for your attention once again, and thank you for Dr. Guillermo. Have a wonderful afternoon. See you next time.
All right, bye-bye.